Assalamualaikum and hi everyone. We are from M3 CDCS 1102F. Today we will present about the application of differentiation for MAT183 Calculus 1. Before that, let me introduce ourselves. Hi, my name is Nurul Jannah Binti Idris. My metric ID is 2022475424.
Hi, my name is Syahirah Binti Ramli and my metric ID is 2022 463374.
Hi, my name is Siti Hanisah binti Latif and my matric ID is 2022821144.
Hi, my name is Syalwina Auni binti Nazri and my metric ID is 2022896512.
This is the application of differentiation, which are related rates or rate of change, analysis of a function, applied maximum and minimum problems, and mean value theorem. So, what is differentiation? Differentiation is a method of finding the derivative of a function. Not only that, differentiation is also a process where we find the instantaneous rate of change in a function based on one of its variables.
The first topic is about related rates problems. What are related rates problems? Related rates problems is problems that involve two or more quantities and their corresponding rates of change with respect to time. The objective of this topic is to determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity. Chain rule or implicit differentiation is often used.
The problem statement. A straw is used to drink milkshake from a cylindrical cup. The cup's diameter is 8 cm. If the volume is decreasing at a rate 2 cm cube per s, find the rate at which level of milkshake is decreasing. The solution. The first step is draw the diagram and label the dimensions. Given that diameter equals to 2r and the solution is shown on the slide.
The next step, we need to extract the information and find the formula that relates to the question. Given that dV over dt equals to negative 2 centimeter cubed per second, the negative is inferred from inclusion of the word decreasing, and we need to find dH over dt. The formula for the volume of a cylinder is V equals to pi r squared h. And using this formula, we can get volume equals to 16 pi h. The third step, we need to differentiate the formula. From the second step, we get V equals to 16 pi h. After we differentiate this formula, we will get dV over dt equals to 16 pi dH over dt. Lastly, solve the differentiation and find dH over dt. From the step 3, we need to substitute dV over dt equals to negative 2. So, after we do the calculation as usual, we will get negative 0.0398 cm per second. Therefore, the rate at which the level of milkshake is decreasing is 0.0398 cm per second.
Okay, second topic is applied maximum and minimum problems. The definition of applied maximum and minimum problems are optimization problems that involve finding the maximum or minimum value of a function. Okay, for maximizing is finding the largest value of the quantity can be, and minimizing is to finding the smallest value the quantity can be. Okay, the objective is we can use this method to solve optimization problems, such as maximizing profit, minimizing the amount of material used in manufacturing an aluminum can, or finding the maximum height a rocket can reach. There are 6 steps to solve the problems. Firstly, draw the diagram and label the dimension. Secondly, find the formula. Third, find the derivative, then equate it with 0 to find the value. And fourth, find second derivative, and then find the value of other dimension if any. And lastly, find the maximum or minimum value. For the second problem statement is, suppose that a manufacturing company wants to package its product in a closed can in the shape of a right circular cylinder. The merchandising department has determined that the volume of the can should be 16 cm3. The first question is, show that the total surface area can be expressed as S equals to 2 pi r square plus 32 over r. The first step is, we need to draw the diagram and label the dimension. Next, we need to find the formula of total surface area of cylinder. The formula is SA equals to 2 pi RH plus 2 pi r square, which r is the radius and h is the height. Next, write the formula of volume of cylinder, which is V equals to pi r square h. After that, express h in terms of r. Given V equals to 16 cm3, so h equals to 16 over pi r square. Lastly, substitute h in the total surface area. Then simplify it.
Next, for question B, calculate the minimum surface area that can be produced. So in this question, we want to find the minimum surface area of a cylinder with volume 16 cm3. Based on the previous question, we have expressed the total surface area as S equal to 2 pi r squared plus 32 over r. To find the minimum value of S, we can take the derivative of S with respect to r. But before that, we need to change the expression to negative indices by writing it as S equal to 2 pi r squared plus 32 r to the power of negative 1. So after we differentiate S, we will get 4 pi r minus 32 r to the power of negative 2. And then we need to set it equal to 0 and solve for r. So in this question, we will get r equal to 1.36557 centimeter. Next, to show that the value of r gives a minimum value of S, we need to do second derivative test. As we can see here, if second derivative is positive, the value of r will give a minimum value of S. But if second derivative is negative, the value of r will give a maximum value of S. So after we derive 4 pi r minus 32 r to the power of negative 2, we will get the second derivative equal to 4 pi plus 64 over r cubed. And then we need to substitute r equal to 1.36557. And we will get the second derivative is equal to 37.699, which is a positive value. Therefore, the value of r gives a minimum value of S. Now, we know that the value of r will give a minimum value of S. So, we substitute r into the S expression, and we will get the minimum value of S is equal to 35.1502 centimeters squared. Therefore, the minimum surface area that can be produced is 35.1502 centimeters squared. As the conclusion, by applying differentiation to this situation, we can assume that differentiation can be used to set a volume value, resolve any other type of difficulty, and solve problems involving volume value. So that's all from us. Thank you.